All right, hey guys, I had someone send me this question. Looks like a review problem. It may be on one of the homework questions, or it could just be in the study plan. I'm not sure. Um, but it says express a sum or difference of logarithms without exponents. So let me get my pens right here. Um, so the important thing here is that I want to express this logarithm that they gave me without any exponents. In short, what that means to me is that I want to expand the logarithm. In other words, they've given me this logarithm in this condensed um, way, and I want to take it and I want to expand it, and I want to do so without using any exponents in the final product. Okay, so guys, if you look back in your notes, I don't have my calculus book right handy, um, but in your notes, you were given seven, maybe eight, but I think it's seven, um, different properties for logarithms, and it explained the properties for how you can expand these logarithms, how you can condense them. So that's there. So I would suggest that if you're not familiar or if you have trouble with those properties, to look back through your notes, go back in your textbook, look in my math lab at the notes that you have available. And that's why I'm able to do what I'm about to do. I'm going to apply the properties that were given to me. Um, so here's what I see. The very first thing that I see here that may give us some trouble is that I have this radical here. Um, I have a root 7 there. And that can be kind of confusing for some of us. But what I like to do is rewrite this. And I know we want to get rid of exponents, and this may be kind of confusing. But to expand this, I've actually got to take that root and write it as a rational exponent. So when I take the seventh root of something, that is the same as raising it to the 1/7 power. Okay. Um, so that's my first step. I'm going to rewrite root as rational exponents. All right, my next step here, I've got to think back to when you first learned about exponents and the properties with exponents. Um, do you remember hearing that when you have a power raised to a power that you multiply those exponents? So that's what we're going to do. What we want to do is take that 1/7 and I want to multiply it times that 9, times that 7, and times that 2. It's kind of like your distributive property. But what the goal here is to get rid of that parentheses, okay? And I know we're trying to get rid of exponents, but what we've got to do is first get rid of that 1/7 on the outside, and then we're going to worry about how we're going to change each one of those individual exponents or manipulate them so that they don't look like exponents any longer. So my next step here is for me to again multiply each one of those exponents. So 1/7 times 9 gives me 9/7. 1/7 times 7, 1/7 of 7 is 1, so that's just going to be y to the first power, and I'm just going to leave it as that. And 1/7 times 2 is going to be 2/7. And I'm not really going to put my exponent there, excuse me, parentheses there just because we don't really need them. But what I have now, or what I see, is that now I have one logarithm. I have log base b of x to the 9/7 all over y z to the 2/7 power. And you have a property that says that when you have division such as this, that I can rewrite that division there as subtraction. So I could actually rewrite this as log base b x to the 9/7 power minus log base b of y z to the 2/9 power. And I could have actually did a few more things there, but I don't want to get ahead of myself. Now you have another property that says that when you are multiplying within a logarithm, that a way that you can expand that is by rewriting that multiplication a, as addition. So I'm going to come down below, and just for right now, I'm going to leave this. I don't want my highlighter. I need my pen. Um, so I want this as log. This is going to be log base b of x to the 9/7 power minus log base b y. And I want to be careful here. Um, if you remember back when, think back to when you're working with exponents or polynomials, just polynomials in general. When you have a minus out front, and you have, other operations going on after that minus sign, remember you need to wrap that in parentheses, those other operations, because sometimes that minus can change the sign of the operations, correct? So what I'm going to do is I'm going to put some parentheses here, and I'm going to say this is going to be minus all of this that I have in those green parentheses. So that's actually going to be log base by plus log base b of z to the 2/9 power. And again, let me put my green parentheses so it matches. I wanted to put that bold. So again, you can see that I have a minus sign there, and that come from the division, but I have to put my parentheses there because that minus will eventually change just close to a negative as well. I've got to remember that distributive property. All right, so in my next step, what I'm going to do is distribute that negative, like I just said, but I'm also going to do something else. What I'm going to do is get rid of those exponents because that was the goal. I want to rewrite this without the exponents. I have expanded this logarithm, but I still have those exponents. Now, you have a property that says that I can rewrite these exponents as coefficients. So, for example, this 9/7 I'm able to bring it out front, and it's going to become a 9/7 times log base b of x. And voila, let me erase that b. Then my eraser is a tad bit too big for me. Log base b of x, you no longer have an exponent. All right, so let's say minus log base b of y. I didn't really have anything there, so I'm just going to leave it as y. But I'm going to distribute that negative through. That negative and that positive there, or plus, that's going to change this sign to a minus. But I did have a 2/9 exponent. And again, my property says that I can bring that exponent out front, and it's going to become a coefficient. So that's going to become 2/9 log base b of z. And if you look at what they gave us there as their final answer, it matches with what we just found.